Hello everybody, my name is Inza. I'm going to talk to you about a small presentation entitled Geometry of the magnetospheric magnetic field via the fast solar winds of solar cycle 23. This is a paper for 6th International Multi-Dimensional Conference on current research drawing. Without further ado, we propose this plan for our presentation. First of all, we start this presentation with an introduction. In the second point, generalities around the relation existing between the Sun and the Earth will be presented. In the third point, we will present the dataset and the methodology adopted for this study. The result of the discussion will be presented to you in point 4. And finally, this presentation will close by a conclusion, following by some acts of reflection for our future works. Aged about 4.6 billion years, whose major component is hydrogen, the Sun, source of life, providing Earth, life and food with a central place in agriculture, is a very active magnetic body in permanent movement. This movement is the consequence of the thermonuclear reaction that occurs at the center of the Sun by the fusion of hydrogen atoms into helium. From the reaction, the Sun loses more than 1 billion kilograms of plasma per second in the form of electromagnetic radiation, flares, and solar winds. However, in our presentation, we will focus on the solar winds. So, solar winds disturb the interplanetary environment and the Earth. Furthermore, we would be incredibly vulnerable to solar storms without a stable magnetic field to protect the Earth. Is that the magnetosphere? By magnetosphere, we mean a vast region evolving under the control of the Earth's magnetic field, which constitute an effective shield prevented the direct entry of energy particles from the solar upper atmosphere. The fattest solar winds can cause damage to electrical systems such as transmission and distribution network, aviation and telecommunication system, or even human health from carcinogenic diseases, depression, fully reproductive dysfunction, immunological change, neutral diseases, etc. In a general way, our study aims at contributing to a better knowledge of the response of the internal magnetosphere to the fluctuation of solar winds. To achieve this goal, we should therefore start by extracting the solar wind quickly from 1996 to 2009, covering the solar cycle 23. Then, evaluate the magnetospheric electric field per solar cycle. And finally, quantify the energy potential per solar phase. For this study, Various spaces packages available in the public domain were used, some as OmniWeb and CDPP for solar wind data, and ISGI and SIDC for planetary and geometry entries. That said, the key parameter to be analyzed are the electric field EY frozen in the solar wind, the velocity V of the solar wind particles, the Bz component of the interplanetary magnetic field, the polar theta angle, the planetary index copy, and the geometry index RR. A data of a period is qualified a good or reliable only if all the above-mentioned key parameters are variable similitudes. For the methodology, the convection of the solar wind plasma in the Earth magnetosphere is described by equation 1, where EY is the electric fusion in the solar wind. On the other hand, the power of the solar winds transmitted to the inner magnetosphere is given by the equation 2. In this equation 2, N represents the density of the solar winds particles. V is the velocity of the solar winds. Bt is the magnitude of the magnetic field, and theta is the clock angle. We are in presentation please in the result. Figure 1 and 2 shows respectively the annual and daily evolution of the solar wind speed during the solar cycle 23. On the figure 1, we note a great fluctuation of the solar wind where a peak is recorded at the end of the solar cycle year 2003. The study shows that the whole solar wind is more accelerated in midday universal time. Figure 3, the occurrence of the solar flux where the faster solar winds represent 75% of the total solar flux. We see that the solar flux amplitude are higher at the end of the solar cycle than at the beginning. The occurrence shows 24, and 53 respectively of the ascendant and descendant phase. The evolution of the magnetospheric convection electric field and the Z component of internal planetary magnetic field is shown in the figure 5 and 6. The correlations are very satisfactory for the whole solar cycle and also for the 2203 peak recorded. These show that 98% of the fluctuation of the electric and magnetic field are caused by the 203 peak. We have represented on the figure 7 the evolution of the electric field and the energy stored by the solar winds. Those two parameters show free state recorded by the magnetosphere, in which the magnetosphere becomes very stressed from 9 to 21 universal time. The good correlation show that the depression of the magnetosphere is caused by the strong circulation of the solar winds particles in the inner magnetosphere. Table Table 1 summarizes the free magnetic state and the energy stored by each state in the Earth magnetosphere. We notice that the magnetosphere inflates on the night side and deflates on the day side with an average speed around 472 km by second. These states show possibilities of a magnetic storm from 9 to 21 universal time. These result as agreement with the north and south fluctuation of the magnetospheric field in the 5-year rate. This figure is corroborated with these seats. In conclusion, our study shows that 76% of the solar winds were under the influence of the fast solar winds. Moreover, the energy stored by the magnetosphere, the electrode and magnetic field involved in place opposition. In addition, the analysis of the field shows three magnetic states of the magnetosphere, including two stable states and one unstable state. Finally, the solar winds are much further in the mainly than in the morning and evening. In the future, inside of deleted the erroneous data, we plan to do a plain interpolation in order to keep a sufficient database to train our models. Also, we plan to conclude a small-scale study of the response of the magnetospheric system to fluctuation in the fast solar winds. Thank you for your kind attention, and we look forward to your suggestion for improving the content in this presentation. I joined a small video of the NASA to understand more this projection. Thank you.